In this AP Calculus example, we're being asked to find the solution to the differential equation, and then they give us this derivative right here, with the initial condition y of 0 equals 4, which means at that point, when I plug in 0, I need 4 to come out of there. It needs to be on it. That doesn't normally help us too much, the initial condition. You might be able to narrow down from a multiple choice a few examples where if I plug in 0 for x, I don't get out 4 for y, but they're pretty good about kind of making sure all the answers have that point on them. So that's not really a big deal when we come to this problem. I almost wouldn't even worry about it except as like a final check. Then the other side of this that always sort of, is this language, the solution to the differential equation. So differential equation is just fancy math talk for derivative. And so what a solution to a differential equation means that when I take the derivative of one of these functions down here, that derivative is going to equal the same thing as I get from plugging stuff into the derivative they gave me. It's kind of a weird way of saying, like, make sure your derivative matches up with this derivative up here. So again, the beautiful part about this on the AP Calc test, is the fact that they're kind of making you do, A, B, C, D, E derivatives until you come to the one that fits that descriptor right there. And so rather than going through 5 derivatives for us right now, I'm just going to kind of focus in on the one that is the right answer, and then we'll go ahead and show you how come it's the right answer. So if we look at option C right now, y equals 4 over 1 minus 20x. What we want to do is take the derivative of this and again see if it matches this differential equation that they gave us. Well, looking at this, I've got two things being divided. So to find the derivative of that equation, I'm going to need to apply the quotient rule. So my quotient rule recipe that I use goes low d high minus high d low, and all of that is over the low squared. So I label the top piece the high piece, the bottom piece the low piece, and then I break it into bite-sized problems. So the high would be 4, the low on this one would be 1 minus 20x. And then I need to go find the d high, which means the derivative of the high piece, and I want to go find the d low, which means the derivative of the low piece. Well, finding the derivative of the high, the derivative of 4, the derivative of a constant is always 0. So that's pretty straightforward. And then finding the d low, working my way through this, the derivative of 1, that's a constant, that would be 0. And then the derivative of negative 20x, following our power rule, we'd bring the 1 down. That gets us negative 20. And then technically we would get x to the 0. But anything to the 0 power is just 1. So we don't really need to write that. So then what I say here is I've got what I call all of my ingredients that I need to follow my quotient rule recipe. So I'm going to follow the quotient rule recipe and see what I get. So dy dx says, first go grab the low piece. Cool. 1 minus 20x. Then multiply that by the d high, which is 0. Then minus, go grab the high piece, which is 4, and multiply that by the d low, which is negative 20. And all of that is over the low squared, so all over 1 minus 20x squared. So right now in this form, it's not easy to kind of compare it up here. The first thing that I would want to do is just clean up my derivative that I just got out. So dy dx equals 0 times anything is going to be 0, so that's going to go away. And then negative 4 times negative 20 is going to get me a positive 80. And then on the bottom here, I have 1 minus 20x squared. And so now what I need to do is see, does that derivative fit with the derivative equation that they gave me, my differential equation? So dy dx equals 5y squared. And you say, well, it doesn't look like it, so what do I do about that? Well, we have a y equation. We started with a y equation right here, and so what we do is we take that y equation and we plug it in for y into this equation and then compare those and see if they match. So plugging into this, dy dx is going to equal 5 times, and instead of y, I plug in what my y equation was. So 1 minus 20x, and all of that squared. And from there, I do a little bit of laws of exponents to clean this thing up. So when I've got a power on the outside, that power gets distributed to all the pieces. So out of there, I get dy dx equals 5 times, and that would be 4 squared on top and 1 minus 20x squared on bottom. And then we just keep kind of running through this. This would be 5 times, and then 4 times 4 is 16 over 1 minus 20x squared. And then final piece, 5 times 16, that's going to be 80 over 1 minus 20x squared. And then I compare that to what my derivative was over here, and sure enough, they're the same thing. So again, it's weird, the language. Solution to a differential equation means the derivative of one of the answers needs to match that derivative equation that they gave you. And usually what you're going to end up doing is plugging your original function into the derivative they gave you and comparing those options. And so this one was option C, and none of the other ones would fit. And if you needed to, just to make sure, you could always, if you wanted to make sure this point is on there, you plug that point into the original function. So y equals 4 over 1 minus, and if I plug in 0 for x, then the answer to that should be 4. And sure enough, I get 4 over 1 minus 0 is 1, so it's equal to 4. So that original point, 0, 4, is on that graph, so that checks out as well. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.